My name is Mrenga Wimali, and I'll be talking to you about the current status of biotech, crop biotech. I work as a research scientist in Kalro, based in Katumani, a station southeast of Kenya. That photo there is meant to communicate to you about the mandate with which Kalro is about, including crops and livestock, and the kind of constraints we are addressing. But for the purpose of this meeting, I will generally concentrate around crop maize, BT maize. So why are we here? Since morning I've been hearing many things, but basically what we are aiming at is to try and have a common message, a common message that is understandable by the famous or infamous Wanjiku. And while we are aiming at that, we are looking at a position of educating the membership. We want to increase the level of awareness. We want to demystify some of the myths that are existing, while at the same time manage the expectations. And finally, we are sharing information since morning. I have a story to tell here. The English alphabet has letters, has 26 letters. Do you agree? How about the Chinese alphabet? Okay, the message is, in every step, let's go with the English. Among the 26 letters, you choose what you choose, arrange it in form to write a given word, so that you are aiming at a specific message. Do you agree? Don't be saying yes all the time, otherwise you will find yourself in trouble with me shortly. So the alphabet for us is meant for you to pick letters that are specific, so that the translation of that letter is specific in its way. When you write that letter, or those words, by choosing those letters in the alphabet, English alphabet, you will make someone either dance, fall in love with you, or other, depending on which part of the alphabet you choose. Do you agree? Say yes again. However, in your choice of those letters, from the same alphabet, you can make somebody, hello? Okay. Now we are talking. When you choose those letters, you are actually looking at some level of specificity of your message. The message that is supposed to go to the recipient. In this case, up to this point today, I am already aware that now you've heard about the word BT more than once. Say yes again. Yes. The message here is that the BT is very specific. Very specific is the only word that I want you to pick from that slide. And from it, we derive different crops. Then we call it BT cotton, BT maize, BT eggplants. Suppose it is you. What will you call you? How does it work? I said underline the word specific. That cartoon over there is just meant to educate you quickly on how it works. And I will quickly mention the specificity with which you have chosen the genes that make those proteins are specific to the control of the borer. That cartoon 1, 2, 3, 4 with the message below is meant to tell you how the insect then works. I'll not go into that a lot more. You've heard there is crossing, and this is happening in a manner that you have to identify a given source of genes, which we have talked about in my alphabetic analogy. You saw that you have to identify what you want to source, the good genes that you want to source, like our sister there is talking about free seed. You have to identify, otherwise the seeds are not just random. This is how it happens, I think Prof mentioned this, I will not go into it, but I want to just quickly drive you that in the development of genetic modified plants, it's a journey all the way from laboratory up to commercialization. For every step has its own regulatory requirements. To be very specific in making a GMO, it is very specific. And that takes you back to that alphabet analogy of the choice of genes, of letters. Now, those specificity has to do with the trait of interest, so that you are not just doing gene modification for the sake of it. It must be specific for a given purpose. Why? These are some of the reasons why we want to do genetic modification. That we want to improve productivity. We want to increase the ability of the plant or the target organism to be able to tolerate certain stresses. And some of the reasons why we do genetic modification is because it takes long to do gene crossing naturally. Maybe there is the gene of interest is absent in the adapted plant, the local plant, or when you do it, I mean, it's time, it takes a long time, it's absent, and that's the only way you can do. There are three other reasons which I'll mention as I recall. We've mentioned a number of things. This is not a new slide, but you can see that within the Kenyan space, all those are experimental materials. Some already are commercial, some are at very different stages, but it's collaborative. It's just a list. So that in your mind as you sit there, don't think about BT maize only, BT cotton. There is more within the Kenyan space. Institutions that have been involved in BT maize research are both local, that's CALRO, international centers, and private institutions. All of them, with all the very institutions coming in with the different strengths, as you may see there. So that's what made what we are calling the WEMA, Water Efficient Maize for Africa project, which I was coordinating for CALRO for many years. Maize in this country cannot be discussed, and without it, generally, we say there's no food. The parameters around why are listed over there. But you notice we are producing less and consuming more. So there's a problem. And a quarter of what we produce is consumed by the insect pests. So actually insects are our competitors for food, and if you with reference to maize. So what do? We've identified the problem called stem borer. And stem borer has been listed among the priority insects as a challenge for maize production. You saw the statistics about it. So while we are trying to understand why the stem borer is a problem, quickly, you notice that we have to study, you have to identify the damage points on the plant, which will give us an indication on why we need to control it. And why we need to control it is because the insect causes damage on the stem along the stover. It causes exits because it has to emerge after laying eggs and eating, and it damages the leaves, which is a factory for the food which we need. I said insects are causing a quarter of they eat what we need. Now, in doing the tests in Kiboko, which is just about 170 kilometers southwest of Nairobi, along Mombasa Road, and also doing the same experiments in Kitale, this is what we were able to identify. I know graphs are normally not very friendly to some people, but bear with me, that's the way I could be able to demystify this. That the BT itself, you can see the long length of the first graph. That is yield. It's compared to the test others material. You see it's giving a 40% yield advantage over. The next thing is that it reduces leaf damage by 60%. Same to the number of holes, they are reduced, you can see there, and also the tunneling. While we do this, there are some activities that are accompanying the work. which means visits, trainings, not just visits like tourism, it's called study tours. And what were we testing? We were testing highland insect borers, and we're also testing the lowlands. In Kiboko, we test the lowland. In Kitale, we test the same material, but with the highland pest. Why? Because we want to see, we're calling it proof of concept. We see how does this plant behave under these conditions. In a pictorial form, you can see that we have those two insects, those two plants, sets of plants in different rows, and you notice that the plant here that is non-BT is actually showing levels of damage compared to the BT vein. You don't need a magnifying glass to say it any better. When we did that experiment, we carried out the experiment in Kitale, and using the same parameters to check, you notice the graph and the trend is also continuing, similar to what we previously checked on leaf damage. Again, pictorially, on the amount of yield that you harvest, and also the damage that you see on the tunnels, on the plants. A similar thing, leaf damage, a repeat experiment in Kiboko and Kitale. Again, you see this. Again, the exit holes. But this is something which I would like you to observe quickly, that when we planted these materials in Kitale and in Kiboko, we were testing the two insect pests, the highland and the lowland. Kitale highland, Kiboko lowland. But as within the same space, the fall armyworm attacked our experiment in the confined environment. And these are the same observations. We did not, the insect fall armyworm insect imposed itself naturally on the crop. And the same, you see, the damage is also reduced compared to the non-BT. In this room today, I heard about concerns. The concerns, probably they were in four general places. We had health issues, which I think as we end into the day, you will be hearing more if you ask questions. Environment issues have been talked about, ethics, playing God, and all this, depending on what you believe in. And the economics, there was a question of patents and who takes away the money after the technology is provided. And then there's also public perception. There are expected results, our benefits. One is that we expect to bridge the gap in terms of production. I said a quarter of what we are supposed to eat from the maize is taken away by the insects. So we really want to, then we want to make it available and affordable. At the same time, it will create jobs, not necessarily directly, but you notice on the processes and all this value addition on maize and the likes, including making feed and the likes. The quick question is that the use of the drought-tolerant insect maize and that is also insect protected will increase the value of the number of bags by about 5 million in all the maize growing counties. These are expected benefits. But in the course of all this, we have also learned that despite having very robust systems in place, we still have a challenge with doubt. All the time you have described the good results, we still have doubt among the very many policymakers. I had talked about the expectations and why we are here, that part of it is to create the awareness. But we also need to go beyond the awareness creation. What do we do with the awareness? And I also want to have demonstrated to you that with that technology, we were by chance able to observe that fall armyworm is also controlled in a confined field trial. Thank you very much for listening to me and the opportunity to look at me as well. Thank you.